simplest difference of square there is that usually everybody starts off with this, is if you have x squared minus 4, you can factor this as, and I usually put the two brackets first for some reason, I don't know, just like filling it in, I guess. But it's the square root of the first guy minus the square root of the second guy, and the square root of x squared is just x, right? And if you do not know your exponents and radicals, stop right now and go to series 2, and I can honestly tell you the place that destroys most people that I've seen, that stops most people from that I've seen from progressing any further in mathematics, it's exponents and radicals. That's why I did a whole series on it. Okay, usually when I get a brand new student, I start with a real number set, and when we start working things through, it's exponents and radicals that we hit a snag that they don't know, that I have to sit there and review the whole thing, and that includes grade 12s that I've had, that includes university students that I've had. Okay, for some reason exponents and radicals destroys people. It's simple, it's just a different level, right? And we talked about this. This is the principal level and just kicking up another level. And in mathematics, when you have your base number here or base variable here, you can put symbols all around it, and there are symbols that go all around this base level that they mean something, right? And the first place you go to is to the exponents when you're going beyond just simple mathematics, where you're dealing with just one level of math, one level of numbers or variables, right? Anyway, that's digressing. So if you don't know exponents or radicals, series 2. Square root of x squared is just going to be x. So you can just go x here and x here because they're both the same thing. So whenever you're taking the square root here, whatever you put here, that's got to be the same thing here. And that goes for this as well. Square root of 4 is just going to be 2 and 2, right? And all you do is just go plus, minus. Or minus, plus. Doesn't make a difference. I'm going to switch them up between plus and minus and plus, as long as they're different, right? Let's do a few more questions. So you could have, variables and numbers mixed together, right? You could have you got 4x squared minus 9y squared. And again, it's just the square root of the first one minus the square root of the second one, square root of the first one plus the square root of the second. Square root of 4x squared is just going to be 2x. Square root of 9y squared is just going to be 3y. So 2x, your choice, minus or plus. Let's go minus. 2x minus 3y times 2x plus 3y. More. We did straight up numbers, straight up variables, variable and number. So let's do fractions, right? Fractions works the same way. We got 4x squared divided by 25 minus 9 divided by y squared. And fractions, again, you take the square root, all you do is just take the square root of the top and the square root of the bottom. So the bottom stays where the bottom is, right? Some people, when they take square roots of these things, for some reason the denominator goes up to the top, which is, I'm not sure how that works, but whatever you're factoring in the bottom stays in the bottom. Right? So all we do, I'm just going to put my brackets down first. So 4x squared divided by 25, the square root of that is just going to be 2x divided by 5, right? And so it's going to be 2x divided by 5 here and 2x divided by 5 here. Right? Square root of 9 over y squared is just going to be square root of 9 is 3 divided by square root of y squared is going to be y, right? So it's 3 divided by y. Right? And your choice, plus, minus, minus, plus. Just make sure you switch it. any two things subtracted from each other you can factor, right? So let's just start off with this. Fairly simple. It's x to the power 4 minus y to the power 4. If we're going to factor this, it becomes right? So it becomes x squared minus y squared times x squared plus y squared, right? Now, again, any two things subtracted from each other we can factor. So we can continue factoring this one, right? Actually, we can continue factoring this one forever, really, but we're going to stop as soon as we get to x and a y, because the whole point of mathematics, the whole point of just algorithm, just trying to factor, is trying to simplify mathematics, not to make it harder. So at a certain point, you're going to have to make a decision to stop because you can't go any further, right? Or you can go further, but it's not going to make your equation or your expression simpler. So this guy we could factor further. This guy we can't factor further because two things added together we can't factor. So if we're going to factor this guy, x squared minus b squared, x squared minus y squared, it's just going to be x minus y times x plus y. This one is going to stay the same. So we're going to have three brackets on this row. Right? So this one factored out into x minus y, x plus y, and that one just stayed the same, so it's x squared plus y squared. Right? And this, if you're going to factor this guy fully factored is here. If you only take it to here, if the question is worth 1 mark, you're only going to get half a mark. You've only done half the job. And from here, you don't want to go any lower, right? You don't want to factor this any further because now you're going to have the square root of x minus the square root of y times the square root of x plus the square root of y times that. So, and then that one is going to have a minus and a plus again, so you can continue factoring the negative, but you don't want to do that. It just makes it too complicated. Now, all the expressions you get to factor, they may not factor properly, right? They may not break down so simply, right? Or they may not break down at all, but you still want to factor them to be able to solve your equations. Equations are where we're going to go with this, right? So you might get some kind of expression like this. So let's say you just have x squared minus 13. Now this one you can still factor, right? Even if you had a y here, you can factor. Doesn't make a difference. You can have anything on this side. You can factor it, right? So you could have, if you're going to factor this, you just make square root of 13y, because square root of 13, that's a prime number. You can't break that up. And y is just y. You can't take that outside of your root symbol, right? And again, series 2. So you got x square root of 13y, x square root of 13y, and you're just going to go plus minus. Let's do a large expression, something silly that we're not really going to get initially anyway, but let's just see how it breaks down if it is large. Something that doesn't factor, something that's got fractions in it. Okay, I have to write this down because there's no way I was going to remember and do it properly. So all this is, the way you do this is the square root of the first one minus the square root of the second one times the square root of the first one plus the square root of the second one, right? So let's just do this. Hopefully you can read this. The wall was not cooperating. It's got bumps on it, so the chalk is not sticking to it. Anyway, square root of 16, x squared over w squared z to the power of 8 is just going to be 4x divided by z, w z to the power of 4. Same thing on the other side, so that's what we have over here. And square root of 50. Now, you're not going to get anything like this, right? Anything silly like this. Hopefully you won't get anything silly like this. But if you do get something like this, all it is just square root of the first one, you put minus the square root of the second one times the square root of the first one plus the square root of the second one. And this is where series 2 comes in, where it's super important to know series 2, because series 2 is about taking square roots of things, either variables or numbers. With numbers, you need to break them down to their prime factors. With variables, all you got to do is just figure out, x cubed means there is 3 q's in there. So if you're going to take the square root, you're looking for pairs. Pairs can come out as singles, right? And we talked a lot about this in series 2. So again, if you don't know your exponents, if you don't know your radicals, you need to stop right now, and what you need to do is take a look at series 2, and you need to become really good at that, okay? Hopefully you've got the gist of it. You understand that just any two things subtracted from each other, you can factor, and you can group things together, right?